Okay, I want to draw your attention to this phrase over here. Solution of the quadratic equation. So quadratic equation will have a x square term. Okay, so for example, y equals to x square plus 3x plus 3, for example. Are there any solutions to this? What do we mean by solutions? Okay, versus an equation that looks like this. X squared plus 3x plus 3 equals to 0. Which one do you think you can solve? Let's change this to minus 3. Okay, this one is minus 3. Okay. Are that here I've got y equals 2. Whereas on this side it is equals to 0. Okay, now I'm going to sketch graph for you. Okay, parabolas for quadratic equations, they are either a smiley face, a parabola opening upwards, or a sad face, a parabola opening downwards. Let's just consider for parabolas opening upwards, okay, where a, the coefficient of x squared, is positive. So we are going to be drawing parabolas opening upwards. There are 3 possible cases that I can have for parabolas opening upwards. I want you to draw in the first parabola as such first. Okay, according to mine, just draw a parabola that intersects this way. Okay, done? Is your parabola symmetrical? Look at your friend's parabola. Is it acceptable? Next thing. Do the parabolas appear to keep opening upwards? Meaning, they appear to extend in these directions and not like this, as well as not like this. These are wrong. They must keep opening. Okay? Next, you look at the shape. Does it look like the upside down water cooler shape? Where you press the water cooler, the water comes out, right? The water comes out from a water cooler, then you flip it upside down. Does it look like that shape? If it does look like, then it's a parabola. If it looks like this, if it looks like this one, obviously your water cooler will not give you this shape when you press the water cooler and let the water come out. Right? You will not see water coming out looking like this. You will also not see water coming out like this. So these are wrong shapes. Rather, the water will come out like this. This is a parabola. Okay? Next, we are talking about roots. So we are talking about solution. And we all agree that for equation number 1, no solution. Equation number 2, sorry, not no solution, infinite solution. Equation number 2, we've got 2 very specific solutions. We've got 2 values of x. And this happens when y is equal to 0. Okay, do you see this? The relationship between equation 1 and 2, it happens when y is equal to 0. What is the line representing y equals to 0 on your x and y coordinate, x and y axis? Which one is the line y equals to 0? Which axis is it? Y equals to 0. X-axis. We are referring to the horizontal axis, which is our x-axis. So this is our x, this is our y. Since we are talking about the roots, we are talking about the intersection between our graph and our x-axis. How many points of intersection do you see? 2 points of intersection. Over here and over here. Right? These are our solutions. These 2 points are our solution. So I give you an example of this graph. This graph could have the equation y equals to x plus 1, x plus 2, for example. So draw it this way, write down the equation y equals to x plus 1, x plus 2. How will you now find the values of these 2 intersections? the two x-intercept. What are these values? If this is my equation. Joban, what do you think? -1 over here, as well as, oh wait, this one cannot be +2, this one is -2. Okay, -1 and 2. Do you know how he got it? How? How does he know that they are -1 and 2? How do you know the coordinates? Enyu, what do you think? How did you get -1 and 2? X plus 1 equal to? X plus 1 equals 0. Okay, so she says that this part should be equal to 0. But why? Because y equals to 0. This horizontal axis is y equals to 0. That's why she let this part be 0. Therefore, we get -1. Likewise, this is also equal to 0. So we get 2. So these are our two solutions to the equation. Okay? Is this the only possibility for parabola opening upwards? Meaning, must parabolas opening upwards always have two points of intersection with the x-axis? Then what other possibilities are there? Besides 2 points of intersection, how many times can I touch the x-axis? Is it possible that I just touch the x-axis at one point only? Is it possible? What will it look like then? Is it above the x-axis? Yes, okay. What about the minimum point? Where is the minimum point situated at? On the x-axis itself, yes. Okay, so for example, we could have a graph that looks like this. Okay, this is a parabola opening upwards. So please draw this, x and y. You see that it is touching my x-axis only at one point. This point over here. So let us give this graph a name. For example, if this is 3, so this graph must be y equals to x minus 3 squared. If you expand x minus 3 squared out, you get x squared minus 6x plus 9. It is still quadratic. We still have an x squared term. And this time, when x is equal to 3, y will be equal to 0. So same logic as what Joban and Enyu used just now. Okay, to get one solution. And then finally, besides case number 1, we've got 2 roots. Where are the 2 roots? Over here. 1 root, 2 roots. This is for case number 1. Case number 2, I've only got 1 root. And then I've got case number 3. How many roots do you think there will be? 0 roots. Can you try drawing a graph that has 0 roots? That means it doesn't touch the x-axis at all. For a parabola opening upwards. Try. Sketch. Do a quick sketch for no roots. That means it cannot touch the x-axis. You will come up with either this graph in red, or you will come up with this graph in blue, or in green, sorry. Either one. Okay, or maybe if you drew it right in the center, also possible lah. Basically, the graph is not going to touch the x-axis. It has to look like one of these. Okay, for a parabola opening upwards. One of these. So what then will be an equation of a graph like this? Okay, let me choose the green one. Suppose your graph looks like this. The minimum point is on the right hand side. I give you an example of a possible equation. This graph has the equation y equals to x minus 1 square plus 1. Okay? Let's see what happens when y equals 0. When y equals to 0, okay, this is if I'm trying to find the point of intersection between the x-axis and the graph. So when y equals to 0, same approach as what Enyu did. When y equals to 0, then she saw that, hey, x plus 1 has to be equal to 0, or this must be equal to 0. So same thing, when y equals to 0, I get x minus 1 square equals to, what do we have? Complete it for me, what do we have? When y equals to 0, so x minus 1 square is negative 1. Is this possible? Is it possible for x minus 1 square to be equal to negative 1? Possible. How do we decide whether it is possible or not? Can you square any number? So I've got a blank, and then you square it, you get negative 1. Is it possible? Possible. You can try any number inside this box. You can try 10. You can try negative 10. You can try 0. You can try any number you want. I am sure you will not get negative 1. Why? Reason is because for whatever you square, okay, it's the same as it multiplied by itself, right? Whatever is in a box. Now, whatever is in a box, there are three possibilities. It can either be positive inside here. It could be negative inside here. Or it could be, this is option number 2. Option number 3, it could be 0 inside here. Let's talk about the case when it is positive. Okay, so positive, positive, positive. When I multiply it out, when I square it, what is my answer? Positive, negative, or 0? Positive. Okay, this is option number 1. Option number 2, if I choose for it to be negative. Okay, so negative over here. When I square a negative number, what do I get as the answer? Still positive. Okay, so option number 1, option number 2, it must be positive. And the last option, I've got a 0. So when you take 0 multiplied by 0, what do we get? 0, 0, 0, we get 0. Therefore, is it ever possible for us to get negative 1? It's not possible. So we say that there are no solutions. Okay, otherwise known as no roots. So in this case, we see that, hey, my x-axis does not intersect my graph. So no solution. In case 3. In case 2, my x-axis intersects my graph at 1 point. So one solution. In the case number 1, my graph intersects my x-axis at 2 points. So there are 2 solutions. And they are x equals to negative 1 or x equals to 2. In case 2, we've got x equals to 3. And in case 3, no solution. Okay? Let's move on to our homework. Drawing a dotted line for the line of symmetry. Okay, simple stuff. Okay, first one. This is my line of symmetry. Do you have any more? Any other lines of symmetry, Kason? No more. Your friends are saying have. Where? Over here? Is this it? Is there any more? Yes, there is one more. Any more? 2 more. Over here. And over here. Okay, so these are the lines of symmetry. What about the heart shape? How many? 1. Okay. What about this half of an oval? 1 also. And what about this parabola over here? How many lines of symmetry? 1. Okay, next. Draw the lines of symmetry for the following quadratic graphs. So quite clearly, it must pass through our minimum point. So this is the x and this is the y-axis. Now very important over here, when you draw the line of symmetry for parabolas, you must write down the equation. What is the equation for this line? Does it start with x equals 2 or y equals 2? The equation of this line of symmetry, you must write down. Does it start with x equals to something or y equals to something? Okay, x equals to something. X equals to what? What is x equals to? What is this value? H. Yes, it is found here. The turning point. So x equals to h. So for your information, this value over here will be k on our y-axis. Okay? Can you tell me whether k is a positive or negative value by looking at the graph? K is negative. What about h? Is it positive or negative? Positive, huh? Okay, let's do the same for the other parabola. Line of symmetry must cut through the turning point. So we also must label the line of symmetry. This will be x equals to h again. Okay, this value over here is h. H in this case will be a negative value. Can? Okay, let's see whether you fully understand what lines of symmetry mean. If there are 10 units over here, how many units will there be here? Very good. If there are 1,000 units here, how many units are there over here? 1,000 also. Okay? So your x-intercepts as well as our line of symmetry, they give us clues of what each other are. So a quadratic function has a vertical line of symmetry passing through its turning point. So turning point could be the maximum or the minimum point. Okay, so the next part, I also ask you to draw the line of symmetry, right? So quite easily drawn. Draw all your lines of symmetry. Okay, then we need to label. So this line has the equation x equals to, what do we have over here? 1. Okay, here we've got x equals to 1 again. And finally we've got x equals to negative 3. Simple? Okay, next one, page 7. Okay, here we've got quadratic equations. So y equals to x minus 2x plus 3. The roots of the equation, hang on. Okay, you see that all these are in the form y equals to x minus a times x minus b. Sometimes a is positive, sometimes b is positive, sometimes they are negative. Doesn't matter. Approach is the same. Okay, so the roots of the equation, like we said, we cannot have roots, we cannot have solutions when it is y equals to x minus 2x plus 3. We need it to be of the form, and this is what you need to write down. X minus a, x minus b equals to 0. Okay, we are trying to solve for the solutions of this equation, x minus a, x minus b equals 0. So now, I will show you an example. Then you will do the rest yourself. For this equation, x minus 2x plus 3, the roots are x equals to 2, x equals to negative 3. Okay? How did I do this? To complete your working, you write down when y equals to 0. So x equals to 2, x equals to negative 3. Does anybody need explanation for this? Finding the roots. Why is it 2 and negative 3? Anybody needs help? If there aren't, I want you to fill up the rest first. For this, the first column. So write down when y equals to 0, x equals to blank, x equals to blank. So there are 3 such questions. When y equals to 0, x equals to something, x equals to something. Fill them up. Reyes, can you give us the answer for the second equation? What are 2 values for x? X is 4. And? Or negative 4. As well as? How much? Okay, 5 over 2. 2.5. Okay, they are correct. John, can you tell us the roots for the next equation? What? Okay, there are some comments about this answer. What do you want to say? Why is it? Why is it negative 4, is it? Okay, who needs help with this question? Raise your hand. Okay, what do you all have as the answer? 4? Okay, let's check. We are talking about when y equals to 0. So when y equals to 0, I've got 0 equals to negative x plus 4, 2x minus 5. So I am trying to find the value of x that leads to the product equals to 0. Okay? This tells me that there are 2 possibilities. Either negative x plus 4 equals to 0 or 2x minus 5 equals to 0. Do you all agree so far? Mechanics okay? Okay, then let's look at this one. This is the easier one. What do we have for x for this case? What is the value for x such that 2x minus 5 equals to 0? 2x minus 5 equals 0, come on. 2x equals to 5, right? So x equals to? 5 over 2. Now what about this side? Negative x plus 4 equals 0. 2 ways you can look at it. Either you go negative x minus 4 equals to 0, or you look at it this way. X plus 4 equals to 0 because you divide both sides by negative 1. Get it? Regardless of what you choose, you will still have x equals to negative 4. On this side, you still have x equals to negative 4. Okay, so these are our 2 values for the roots. Negative 4 and 5 over 2. Okay, John, your turn. Last one. What are the roots of the equation? Yeah, when y equals 0, x equals to? How much? Negative 1 and half. Like this? Oh, negative 1 half. So negative 3 over 2 as well as 1. Okay, correct. Okay, these are our roots so far. So now, I want you to be able to tell me, are these parabolas opening upwards or downwards? Positive, so it is a parabola opening up. Okay, do a quick sketch over here. Parabola opening up. Okay, next one. Equation number 2. What is the coefficient of x squared? Is it positive or negative? Negative, so parabola opening down. Draw parabola opening down. And the last one, coefficient of x squared, positive or negative? Positive, so parabola opening up. Okay, this is our sketch for now. And we also need to include our roots of the equation, 2 and negative 3. So how many solutions are there? How many solutions do you see? Hey, 2 and negative 3, how many solutions? 2 solutions, right? So how many times will it cut my x-axis? 2 times. Where will the x-axis be? Is it gonna be here, here, or here? The third one, you must cut at 2 points, right? So it has to look like this. X-axis. And what are these values?
Negative 3 and 2.
On the left hand side, is it 2 or negative 3? Okay, negative 3 and 2. Can you do the same for the other 2 graphs? Okay, class? For the second equation, x-axis over here, first value is negative 4, next value is 5 over 2. Last one, again we have 2 values. First is negative 3 over 2, next is 1. Hey, does this look like a complete sketch? What's missing? Y-axis, right? Based on these 2 values, do you think you can tell where roughly the y-axis is? So question, is the y-axis closer to negative 3 or closer to 2? Common sense, right? Logic, right? Because it's 3 units away from the y-axis and 2 units away from the y-axis. So draw in your y-axis. Okay? Now tell me your minimum point. Is it closer to, is it on the left or the right side of the y-axis? Look at your minimum point. Is it on the left or the right side of your y-axis? Must be left side, isn't it? Can you tell me the x-coordinate of the minimum point? Can you tell me the x-coordinate of the minimum point? Since it is symmetrical, the minimum point must be in the middle of the 2 x-intercepts, right? Okay, so what is in between negative 3 and 2? Negative what? 0.5. How do you get negative 0.5? 3 plus 2? Oh, okay. Negative 3 plus 2 divided by 2. So finding average. Basically, you're finding average. Okay? So in the middle of negative 3 and 2 is negative half. So this value over here has a minimum point of negative half, comma, something else, a blank. I'll leave it as a blank first. Okay, we'll fill it up later. Can you do the same for the other questions? Your line of symmetry, you must draw it down. Okay, so this red color line of symmetry, x equals to negative half. Okay? So do the same for the other 2. Drawing your y-axis, drawing your line of symmetry. Okay, class? Look at the screen. For the second case, where is my y-axis? In a closer to negative 4 or closer to 2.5? My y-axis, closer to which one? Closer to 2.5. Okay. Then let me draw my y-axis over here. Y and x. What about my line of symmetry? X equals to negative 3 over 4. This is my line of symmetry. So my maximum point will have the coordinates negative 3 over 4, comma, blank. I'm not going to fill it in yet. I'll fill in later. Next, last case. My y-axis closer to negative 3 over 2 or closer to 1? Closer to negative 3 over 2 or 1? 1. Closer to 1. Just a bit closer only. So y axis and my line of symmetry. This will be x equals to negative 1 over 4. Negative 1 over 4. So my minimum point will be negative 1 over 4, comma blank. Our job now is to fill in all the blanks. All the y coordinates of the turning point. How do we find it? How do we find this unknown over here? Sub what? What is the x coordinate in this case? Half or negative half? Negative half. I substitute my negative half into the original equation to find the y value. Just do that, it's as simple as that. So when x equals to negative half, y equals to negative half minus 2, negative half plus 3. And we get a value of negative 6 and 1/4. So this is my minimum point, negative 6, 1 over 4. Okay? Then also fill in your line of symmetry, which is x equals to negative half. I want you to also highlight this part, x equals to. When x equals to negative 3 over 4, y equals to, then fill in the blanks. Negative times negative 3 over 4 plus 4 multiplied by 2 times of negative 3 over 4 minus 5. So it's just simple substitution. And we get a value of 21 and 1 over 8. So this maximum value will be negative 3 over 4 with 21 and 1 over 8. With the line of symmetry as x equals to negative 3 over 4. And now the last case, when x equals to, at the minimum point, when x equals to negative 1/4, y equals to 2 times of negative 1/4 plus 3, negative 1/4 minus 1. And we get a value of negative 3 and 1 over 8. Then the line of symmetry will be x equals to negative 1/4. When x, I'll use another color, let's use blue. When x equals to 0, y equals to, okay, tell me the answer straight away. Mental sum, don't need calculator. 0 minus 2 is negative 2. 0 plus 3 is 3. Negative 2 times 3 is negative 6. So the first one, y is negative 6. Hey, check. Yeah, it's over here, negative 6. Okay, that's the y-intercept. Next, when x equals to 0, y equals to, okay, mental sums quickly. How much is it? $20 or negative 20? 20. So this value will be 20. Last one, when x equals to 0, y equals to how much? Negative 3. So check whether everything makes sense or not. This value, negative 3. For A and C, y equals to 0. Therefore, we've got x squared plus x minus 6 equals to 0. Okay, so now we have an equation that we can solve. Do you know how to solve this? What is the step to solve this? Factorize, yes. We have to factorize this, and that will give us x. Okay, do it step by step. X with x squared. So here we have negative 6 and x. 3 and 2, 2x, 3x. If I want a positive x, I require negative 2x over here like this. So it is factorized, become x plus 3, x minus 2 equals to 0. What then are our values of x? Okay, x equals to negative 3 or 2. Can you now determine or can you give me a comment about this sketch over here? Not drawn to scale. In fact, it is quite a poorly drawn graph, isn't it? Why is it poorly drawn? Yeah, you see, it is supposed to be 2 units over here and 3 units, right? So it is very poorly drawn, but we know that the C will be 2, whereas for A will be negative 3. Okay, so the coordinates for A will be negative 3, 0. For C will be 2, 0. That's for A and C. Is it the same approach for straight line graph? When you want to find the x-intercept, do you also let y equal 0? For your straight line, you want to find the x-intercept, do you let y equal 0? For example like this, if I have a graph that looks like this, y equals to 3x minus 2. Then I ask you to find the x-intercept. How will you do it? How will you find this? Let's say this is point A. So at A, y equals to 0, isn't it? So we have 3x minus 2 equals 0. X equals to 2 over 3. So this is 2 over 3, 0. It is the same approach. We let y equals to 0. Then we solve for x. Same thing over here. Let y equals 0, solve for x. Same. Just that for quadratic, for this parabola, we will need to factorize. In our linear, when it is a straight line, there's no factorizing to be done. Understand? So now, we still need to find the B coordinates. What is so special about point B? Yes, at B, x equals to 0. Therefore, y equals to... do you need to do substitution or can you just tell me the answer? How much is y when x equals 0? Look at the equation. How much is it? Negative 6. No need to do any working. So the coordinates of B will be negative 6, 0, negative 6. Okay? That's all. A, B, and C. Now you get to try example 2 yourself. Okay, do this now. You've got 5 minutes. Until 1:38. Once again, for the line of symmetry, you need to write down x equals 2. Do you have that?